The 21st century dawned with the promise of renewed space exploration. Private companies joined nations in this grand endeavor. Among them was Boeing, an aerospace giant with a storied history. Their project, the Starliner spacecraft, designed to ferry NASA astronauts to and from the International Space Station. This was a critical task. It marked America's return to human spaceflight from its own soil. The Starliner represented hope. It was a symbol of technological prowess. It carried the dreams of countless individuals who yearned to touch the stars. The initial launch of the Starliner, however, did not go as planned. What was supposed to be a smooth ascent into the cosmos quickly turned into a series of unexpected challenges. Technical glitches plagued the mission from the outset. Engineers and astronauts alike were on edge as they scrambled to diagnose and fix the issues. Software bugs threatened to derail the entire endeavor. Error messages flashed across screens, and programmers worked tirelessly to debug the code. Design flaws became evident, causing concern among engineers and astronauts alike. The spacecraft's design, which had been meticulously planned, now seemed riddled with unforeseen issues. Testing failures further eroded confidence in the spacecraft's reliability. Each failed test was a blow to the team's morale, casting doubt on the mission's success. On June 5, 2024, the Starliner embarked on its maiden voyage. The countdown to launch was filled with anticipation and anxiety. It was meant to be a momentous occasion. Families and friends of the astronauts gathered, their eyes filled with hope and pride. It turned into a nail-biting ordeal. The atmosphere in mission control was tense, and the astronauts inside the spacecraft could feel the weight of the situation. The spacecraft encountered a series of problems during ascent. The rocket shook violently, and the ascent was far from smooth. These included thruster issues, communication blackouts, and software anomalies. Each problem compounded the next, creating a cascade of challenges. The mission, originally intended to be a short trip to the ISS, was forced into a dramatic detour. The spacecraft had to change course, and mission control had to quickly adapt to the new plan. Astronauts. Butch Wilmore and Sunita Suni Williams, on board the troubled spacecraft, found themselves in a precarious situation. Their training had prepared them for many scenarios, but this was unprecedented. Their training had prepared them for many eventualities, but not for this. They had practiced emergency procedures countless times, but the reality of the situation was far more daunting. Stranded in orbit, Wilmore and Williams faced a unique set of challenges. Their mission, which was supposed to be straightforward, had now become a test of endurance and ingenuity. Their carefully planned mission had been thrown into disarray. The unexpected extension meant they had to rethink every aspect of their stay. They were now forced to adapt to an extended stay aboard the ISS. This required not only physical adjustments, but also mental resilience to cope with the prolonged isolation and confinement. The space station, designed for a specific crew size and mission duration, had to accommodate their unexpected presence. This meant reconfiguring living spaces and reassigning duties to ensure everyone's safety and well-being. Supplies, originally meticulously calculated, had to be rationed. Every meal and every resource had to be carefully managed to last the extended duration. The astronauts' daily routines were disrupted, requiring flexibility and resilience. Exercise schedules, work tasks, and even leisure activities had to be adjusted to fit the new timeline. Wilmore and Williams, however, rose to the occasion. Their camaraderie and teamwork became crucial in maintaining morale and efficiency. Their years of training and their unwavering professionalism helped them navigate this extraordinary situation. They drew upon their extensive preparation to handle the unexpected challenges. They worked tirelessly with ground control to troubleshoot the Starliner's problems. Constant communication and collaboration were key to finding solutions. They also assisted the ISS crew with their ongoing experiments and maintenance tasks. Their contributions were invaluable in ensuring the continued success of the mission. Section 4. The body in space, adapting to a new reality. The human body is a marvel of adaptation. However, prolonged exposure to the harsh environment of space takes its toll. Weightlessness, while exhilarating, can lead to muscle atrophy and bone density loss. Radiation exposure increases the risk of cancer and other health problems. The immune system, compromised in microgravity, makes astronauts more susceptible to infections. Wilmore and Williams, like all astronauts on long-duration missions, experienced these physiological changes. They followed rigorous exercise regimens to mitigate muscle and bone loss. They wore dosimeters to monitor their radiation exposure. Their health was constantly monitored by a team of medical experts on Earth. Section 5. The mind in microgravity. Psychological effects of prolonged isolation. The psychological impact of extended space travel is as significant as the physical toll. Spending long periods in space can be mentally taxing, affecting an astronaut's emotional and cognitive well-being. Confinement, isolation, and the lack of a natural day-night cycle can disrupt circadian rhythms and affect sleep patterns. This disruption can lead to chronic sleep deprivation, which in turn impacts cognitive functions and emotional stability. The monotony of life in a confined environment, coupled with the stress of being in a hazardous situation, can lead to anxiety, depression, and interpersonal conflicts. The constant awareness of being in a potentially life-threatening environment adds to the mental strain. Astronauts undergo extensive psychological screening and training to prepare them for these challenges. This preparation includes simulations of space missions and scenarios to help them develop resilience and adaptability. They learn coping mechanisms and communication skills to maintain their mental well-being. Techniques such as mindfulness, relaxation exercises, and effective communication strategies are essential tools in their psychological toolkit. During their extended stay, Wilmore and Williams had regular psychological consultations with ground-based therapists. These sessions provided them with a safe space to discuss their feelings and receive professional support. They also had access to entertainment and communication tools to stay connected with their families and loved ones. These connections are vital for maintaining a sense of normalcy and emotional support, helping astronauts to cope with the isolation and stress of space travel. Section 6. A financial and operational black hole. The Starliner's troubled mission had far-reaching consequences. The financial implications for Boeing were substantial. The company had invested billions of dollars in the development of the spacecraft. The delays, technical issues, and reputational damage resulted in significant financial losses. The operational impact on NASA was equally profound. The agency had been relying on the Starliner to provide reliable crew transportation to the ISS. The delays forced NASA to rely more heavily on its other international partners for crew transportation. It also raised questions about the future of commercial crew programs. The incident highlighted the inherent risks and complexities of spaceflight. It also underscored the importance of rigorous testing, quality control, and robust backup plans.